I can see some people trickling in. How's everybody doing today? I think we're just gonna wait a couple more minutes, let some more people come in, and then we'll get started. Hey, Corey. Look at this. This is so fancy. While we're waiting for people, I'd love to hear in chat what you're looking forward to learning today, so I can make sure we cover that. Right. I think we're gonna wait one more minute, and then we will get the show on the road. Oh, that's a good question. All right. When we are load testing our server, do we use actual DB or use mock services like MSW? Depends what you're testing. So generally, if you want to see like, is my database connection pool going to hold up to the traffic we're looking at? You might want to use a real DB. You may want to use a copy of your DB, so an isolated environment kept in parity with production. It's probably the safest way to go. But you can use mocks too. I mean, that's fine. It depends, right? If you care about like your server latency, you could probably mock the connection. You're gonna see. I actually have a mock service we're gonna use today for the actual live demo. So, awesome. Let's get this started. So, welcome to our webinar. This is load testing with Grafana K6. We're gonna be breaking some stuff today, and then hopefully fixing some stuff today, depending on how this demo goes. So I want to start with kind of the basics of K6, how to set up a script. This will not be comprehensive, but it will get you far enough to kind of write a script and get going. So without further ado, what is load testing? Load testing is the practice of sending varying volumes of traffic to a system for the purpose of observing performance, right? You can think about local testing. We write some code, we run it in Docker or something like that. We send a single request to it, and it works. And that's great. But as soon as we release that to production, it's not the environment our code is going to live in, right? It's kind of working software versus running software. And load testing helps us see what our running software looks like. So why do we load test? There are tools that help us scale, and they don't exist locally, right? So load balancers, auto-scaling configurations, things like that can only be tested in production by sending real traffic or something production-like. There's also classes of problems that don't exist without, kind of constant load against the server. So memory leaks and race conditions are two such problems that load testing can really help find when we run these tests. So let's talk about K6 and how we actually set up a script. There's a couple of basic things for setup. So at minimum, you want stages, right? These will kind of define how traffic ramps up against your server. So we set durations. So you can see here in my example to the right, we have two stages. One is like a 2-minute ramp up to 2,000 virtual users. These are virtual users are like what K6 considers threads. They all generate traffic. So this would be 2,000 concurrent users. And then we can see here a spin down stage of 1 minute, bring this back down to 0 concurrent users. There's also a threshold setting. So this you can actually use to set tests, and I recommend you do that. So you can see we have 2 thresholds that we care about. One is our failure rate. We want it to be less than 0.1 or 0.01, excuse me. And we have a duration that we care about. So we care about latency. And our P95 should be less than 4.5 seconds, which you'll see when I show you the mock service we built. It's absolutely terrible. And this will be great if we can actually hit this. So next, there is the actual testing lifecycle, right? You have 3 stages, right? You have a setup, which you actually build by exporting a function called setup, right? And here we could do something like create a user that we're going to use for testing. We could do some auth so that we can like fetch a password or set a cookie for our requests. There's the actual test step, which is our default function that we export. It will receive the data that is returned by the setup, and it will run our actual tests. So here you can see we're just doing a basic HTTP GET, and then we are sleeping. And then there's teardown. So maybe if we created a tenant or a user in our setup, we may want to tear that down and delete it. Any number of things from the setup that we might want to get rid of. Here are the out-of-the-box results for K6. If you're kind of using the red metrics, requests, request errors and duration, you'll get all of that from here. So you can see this is a load test I ran last night. We have our HTTP request duration. This is like total duration of a request, including like waiting and blocking and all that stuff. We have our failure rate, right, which luckily in this load test was 0, but hopefully we're gonna see something much higher than that in our first load test today. And there's some basic information about the test you ran. So data received and sent. This is always good to make sure your load tests are working. Iteration duration, iterations, and VUs are just kind of statistics for like how big your load test was. Moving on. Let's talk about like the different strategies that you can use to load test. We'll start here with the smoke test. This has less to do with what your script does to a server or a system, and more to do what the system does to your script, right? So we're really just testing. These are going to be short. You'll see here, I set up my duration to be like 5 seconds with a concurrent user. I'm literally just looking to make sure that like my script works. It hits everything. I didn't break, or I didn't type in the wrong URL or something like that. Throughput's going to be low, and our duration's going to be super low. I mean, 30 seconds is pretty extreme. Like 1 to 5 seconds is probably where you want to be. Getting into like the real strategies, we have an actual load test, and this is to like make sure your system can handle some amount of traffic. You should use kind of any benchmarks you have for the average amount of load that your server sees. We should kind of use something like that. And we're going to do a gentle ramp up. We're going to actually keep the number of concurrent users high, like at production average, for anywhere from 5 to 60 minutes. And then we're going to bring it back down for 5 minutes and kind of take a look at how our server performed, right? But this should be kind of production baseline, maybe a touch over, but just making sure your thresholds are meeting your SLAs and SLOs for error rate and latency. Excuse me. Next, we have the stress test. This is where you kind of go significantly above your production average to kind of see how much headroom you have. This is where you're going to kind of see stuff begin to fall apart. The throughput is generally 5 to 25% above your production baseline. I've used that in the past, and that's been pretty good. Again, your duration is 5 to 60 minutes, so nothing extreme there. You'll see that this is stress/break test. Break tests can go on infinitely until your server just like crumbles. This is really, really fun. But if you do it in production, somebody's going to get really mad. And generally, like, it causes a lot of problems, especially in like persistent data stores and stuff like that. So break tests, although fun, I don't recommend doing. Maybe doing stress tests and then like increasing it a little bit here and there is probably good. If you have an isolated environment, break test away. But stress tests are usually more useful. The next strategy we have here is like a soak test. These are very, very long, and they're made to find memory leaks. They're made to find like race conditions, right? We're gonna go for a very long time, slightly above our production average. And this will allow us to find like weird performance issues that would probably only show up, at 10 a.m. when the marketing email went out, and we saw our servers restarting for a couple hours after the marketing email. This will find all those weird intermittent issues and help you fix them. And finally, we have a spike test, right? Like, spike tests are really, really useful because, especially if you're in kind of B2C industries where, like, marketing will go out, your company was on Shark Tank and the rerun just went on and everybody's kind of visiting your site, or maybe you're in some content-driven industry and your content gets syndicated and now you're suddenly way above what you expected. Spike tests will help you kind of prepare for this. Generally, your server's not gonna survive, and that's okay. Like, you want to prepare for this. So it's a rapid up and down. You'll see here in the stages, right? Rapid up to 2,000 over 2 minutes. You could probably even do that over 1 minute, and then maybe you hold it, I don't know, for a minute or two and then down. But it should be substantially above what your production average is. Otherwise, it wouldn't be a spike. It would just be a normal day. And it probably shouldn't last more than 10 minutes. So I want to get to a live demo, but before I do that, I want to see if we have any questions about kind of the basics of load testing before we break something. Feel free to drop questions in chat. Nothing? I'm that good at explaining stuff? I can't believe it. All right. Well, we can get into the live demo then. So I can continue to give free information so long as I do a little bit of advertising for MassDriver. So this is going to be the quick 2 minutes of product placement. The thing we're going to be breaking today, I built with MassDriver. I may be biased, but I love working with MassDriver, right? We have a really simple infrastructure here. We have a VPC in AWS. We have a Kubernetes cluster, and we have an app running in that Kubernetes cluster using the fake service container. And I've built an application template that allows me to do all sorts of cool configurations, including like modifying CPU load, memory usage, and I can actually set the percentile durations that we're targeting for for this app, all with a beautiful kind of UI. It gives me all sorts of data conversion fields, time conversion fields, so I don't have to do all the crazy like byte math in my head. And we're going to see here, I have no horizontal pod auto scaling. So I just have a single replica of our fake service here. And we're going to send 200 concurrent users at it for about 2 minutes. And we're going to see what happens to my poor little service here. So here we are. Here's my basic script. You can see here, we're importing HTTP from K6. This is just the HTTP library that K6 uses to run its tests. We're going to, for 30 seconds, spin up to 200 concurrent users, or VUs, as K6 describes it. We are then going to maintain that 200 for about 90 seconds, and then we are going to spin down to 0 over 10 seconds. And what I'm looking for here is an error rate of 0.01 or better. And I'm looking at a P95 of 4,200 milliseconds. So you can see here, I have set the P90 duration to 4 seconds. So this should be achievable, assuming everything scales appropriately. I'm going to give you a spoiler. It is not going to scale appropriately, and we are going to break this. You'll see here my default function. This is what my VUs are actually going to do. They're literally just going to hit checkout.mdawsspx.com, which is where my fake service is actually running. So without further ado, let's watch this blow up. So we are going to run. We would be running our script here. I have a Docker compose. And we are seeing our ramp up. You'll see our VUs slowly ramping up. You'll see we have about 40 iterations complete at this point. If we look over here, we'll see slowly the lonely service on my Kubernetes cluster over here start to get hammered with requests. I think we really upset it. It's going to be interesting. Any questions about what we're seeing while we wait for this to finish? It's going to be, I think we're coming up on like the halfway mark at this point. Given how fast all of these things are completing, I have a feeling that we absolutely destroyed this, which is fantastic. Okay, so HTTP request failed. Look at that. 99% of our requests failed. And the couple of requests that actually went through had a P95 of 86 milliseconds. That's probably because we dropped most of the requests on the floor. This is to be expected. So what happened here? We flooded our single replica on Kubernetes with a bunch of requests. The average response time was about 4 seconds. So everything just kind of backed up. And eventually there were timeouts, I'm sure, and we crashed something. As you can see, we now have our single replica back up. But this is About as big a failure as we could have gotten, which is great. This was the one thing I was worried about, is maybe like not getting just a huge bang. So fantastic. Let's correct the problem now that we know what the problem is. We can correct the problem by enabling auto scaling here, right? We can keep our min replicas at 1. I don't think that's going to be appropriate, but like, let's start conservatively. We'll do our max replicas at 6, and we'll start at 75% CPU utilization. That's still a lot of headroom, but we know we need it. So let's run. Again, soft sell. This is so easy with mass driver. This is why I use it. So you should check it out if you're not currently using it. Every user, okay, that's a good question. Is every user running in its own VM? No. K6 is pretty interesting. So you write JavaScript. It compiles down to something that is multi-threaded, maybe Go, maybe something else. And so each one of those VUs is actually running in a thread, and they are very light and very inexpensive. And so we can get a lot of them even on a single system. I've heard of people on sufficiently large machines getting up to 5,000 users. I know if you use K6 Cloud, there are people that have gotten 500,000 plus users concurrently. So this is really, really efficient. On my laptop, I was able to get 500 to 600 concurrent users, which was enough to break down our example here. All right, so let's take a look here. We still have our lone replica because we did set our min replicas to 1. But let's start this test again, and let's see what happens to our system. So same exact thing, spinning up to 200 users, keeping it there for 90 seconds, and then spinning down over 10 seconds. All right, so we can watch this go. So this number kind of going up slowly is kind of what we want to see, right? That means like requests are actually being handled. Unlike the last situation where it was literally just like failure, and we were able to do like 30,000 iterations. That's a sign that something is very, very wrong. If we look here, we will eventually get some information about the load on this server. Metrics not available, probably because we just deployed out, but that will show up in just a minute. We are now at our peak user count, so we should be causing some trouble at the moment. Again, we're still slowly clicking up. And I think we reached the edge here. This is probably not going to do it. Yeah, we're about to see a ton of failures come in. We might have to be more aggressive in this next iteration. Yep. That's all failures at this point. We knocked it over. All right, we're in the spin down, so we get to see just how bad that was. All right, comparatively, actually worse in every way, shape, and form. All right, let's get more aggressive. So let's start with a better base, right? We're going to say at minimum, we're going to want 3 replicas to start. Let's go up to 12. And let's be a little more aggressive here. Let's say we were targeting 75% usage. Let's see what 65 feels like. That feels wasteful, but given the nature of this test, that might be what we need to like actually complete this test. So let's deploy that out. On the every user running in its own VM, there actually is also a way. If you don't want to use K6 Cloud, you can actually. There is a way to distribute multiple test runs through a Kubernetes cluster and actually merge those results so that you can kind of get an aggregated view of how all those test runs went. I did not do that for this, but because it's a little more involved. But if you're doing some serious load testing and you need kind of that upper range, like the 20,000, 30,000 user range, that is an option. Okay, so we've got our base 3 replicas up and running right now, which is great. We're going to start this test again, and hopefully we will see everything scale up appropriately. So ramp up time right now. Again, 30 seconds ramp up, 90 seconds, we're going to hold that 200 users, and then 10 seconds, we're going to ramp down. Okay, we're starting to see some of our replicas. The CPU rate is going up. They should trigger some auto scaling. We should see that come any second now. Instead, we're seeing evictions across the board. All right. It actually looks to be holding better, though, despite that. A couple of timeouts. Okay. Now we're in spin down, which is great. Okay. So HTTP request failed. We did a ton better here. We're down to 25% failure rate. I mean, it's still not what we want. We're starting to see more realistic averages in request duration. Our P95 is at 1 minute, which is really not what we want. So we're going to run this one more time, and we're going to try and just scale this as far as it will possibly go, and see if we can get something better. This is our last shot. Let's cross our fingers and hope for a win. we'll start up min replicas at 5, and let's go to 20. Keep the target CPU utilization the same. It felt like the scale up was okay. It's just we need more. Need a little more power. All right, let's deploy those changes. Awesome. All right. Let's get ready to run this one more time. Hopefully we at least get close to our target. But this is the process with load testing. You're gonna run a load test. You're not gonna do as well as you hoped. You're gonna make some changes, and then you're gonna come back and do it again. Hopefully your application is wildly successful, and this is like a constant problem for you. I don't know what's going on here. This is what I get. I was telling Lou, our salesperson, that the only thing that could possibly go wrong is that I don't break the the environment that I set up, and it seems like the actual problem is like I actually can't get it to respond the way I want it to. The irony of live demos. All right, and even worse. Well, we tried. We were unable to get this to scale up appropriately, but there's lots of potential problems. I think I might have modified the memory load per request, which in Kubernetes land is a non-compressible resource, so it's probably actually evicting my pods instead of scaling the way I need to. We actually can test this real quick. So we can pretend here that we made some optimization. Memory load per request, if we do this in kilobytes instead of megabytes and deploy this out, all this is going to do is make our fake service more memory efficient, which I wish building applications and optimizing memory applications was that easy in real life. So we'll just enjoy the fact that it was that easy this time. Deploy this out and see what we can get going. right, provisioning is complete. We should see them come up in just a couple minutes or a couple seconds. Not quick enough. Let's run the test and see what happens. Can't break it any worse. If I crash the metric again. I don't want to speak too soon, but we haven't seen any request drop yet, which is probably a good sign. Who would have thought making your application more memory efficient would help? All right, coming down to the scale down. Well, would you look at that? 0% failed. All right, so we found our problem. We had a memory issue. We optimized, and that helped. Our P95 duration, still higher than we want. I will say that, like, because this is such a short test and because we caught so much of kind of the scale up in this, P95 is probably a little lower. This is why they kind of recommend going for longer on a load test. So if we went closer to 60 minutes, that would have evened out over time once we kind of hit peak. And that's really what we're looking for. No system is going to catch 100% of kind of a dramatic spike up. So we're looking to get as best as we possibly can. And this might kind of be that. So yeah, we fixed something. That's great. With that, any kind of questions about what we saw? Any topics you want to cover? I'm free and open to questions here. All right. Does K6 have any visual output like graphs? No, not natively. But there are a ton of data sources that you can actually send metrics to, like timescale, like Prometheus, and you can use tools like Grafana to actually visualize these graphs. So out of the box, you kind of just get a standard output, but like that, you can also output to like JSON, or you can kind of export metrics over time to like a bunch of different sources. So K6 testing is part of CI/CD with Jenkins. I have never personally done that. And I don't know, I don't know that you want to unless you're kind of spinning up an ephemeral environment to do it, right? So if you're kind of using CI/CD to kind of deploy out infrastructure changes, and you want to do a load test to make sure that like you don't lose any performance with that change, like that makes a lot of sense to me. I think for every like feature PR, if you're doing like a load test, that may be more. That may not be as beneficial as you think, and like the ingress and egress costs for the cloud can get expensive. So maybe you want to do it once a night with like all the deploys that you did, and you can kind of automate that. That's kind of how I would do it. Maybe it's just like on a cron at the end of the day when like that traffic's isolated and you're not ruining the experience for other users. Are we pointing to one URL only? You can actually you can point to as many as you want, and you can do interactions. So you can hit a URL, get a response, then maybe hit another path on that URL, get a response, right? So you could think about it like adding. You could send a post request to add an item to a cart from a catalog. Then a get request to fetch the cart, and then maybe like a submit. You can do all of that. I tend to split front end and back end in the stuff that I build. So I'm more of an API tester when it comes to load testing. But K6 has some amazing browser testing tools that you can find in their docs. They actually have a browser extension too that can record your clicks and build the script for you, and then you can run it. So if you want to do browser tests, that is an option for you. I just, for this demo, was a very simple single request, single endpoint. Good. Any other questions? Awesome. Well, thank you so much for coming. I appreciate you taking your time out of your day and spending it with me. If you have any other questions or you just want to talk about load testing and infrastructure in general, my email is dave@massdriver.cloud. Feel free to reach out, find me on LinkedIn. If MassDriver looks interesting and we can help you scale, schedule a demo, reach out at massdriver.cloud/contact. Thank you, everybody. Have a good day.